three examples regarding the derivative of common logarithm, LOG. So the derivative of common logarithm, this is log base A of x. The derivative of that is 1 over x times ln A. If you recall the derivative of natural logarithm ln, the derivative of ln x is 1 divided by x. So for common logarithm, if you change the base A to base E, then this base A becomes base E. What is ln E? ln E is equals to 1. So when the base is E, so log base E is just a natural logarithm ln. So for natural logarithm ln, since ln E is equals to 1, that's why the derivative is just 1 over x. There is no ln E at the bottom of the derivative of ln. So the way I memorize this is I memorize ln because the derivative of ln is so popular in both differential and integral calculus. The derivative of ln is 1 over x. For common logarithm, I know that we have to also mention the derivative of the base. Okay, so one more thing for the base, if the base is not specified, then we assume the base is 10. So if that is if just a derivative of log x, then this is 1 over x times ln 10. Okay, back to the problem. We have a base 10, so immediately y prime, we put everything in the denominator. So the x is 2 minus root x plus cotangent x and then times ln 10. If I erase the 10, so let's say the problem I did not mention what the base is, then you assume it is 10. 1 on top, and then we have to use chain rule to multiply, right? So this is the derivative of the parenthesis. The derivative of 2 is equals to 0. And then what else? The derivative of 2 is equals to 0. And then the square root, you take the 1/2 down, x to the negative 1/2. And then the derivative of cotangent, that is negative secant square. So minus CSC square x. And then that's it. So to put this in a more compact form, you can simply put this in the numerator. All right, so for the next one, the one in blue, we have log base 6, one term times the other term. The reason I make this problem is because I want to go over the properties of log. So for log a times b, what is that equal to? That is equals to log of a minus log of b. What if I have a divided by b? Oh, sorry, that is log of a plus log of b. If I have log a divided by b, then you change the plus to a minus. One other important properties to remember is log a raised to the n. You can bring the n down to the front. So n times log of a. And then for the second function, we will rewrite the function first. So the rewrite is g of x equals to log base 6. We have x squared, and then we carry the 2 down in the next step, and then plus log base 6, and then parenthesis, we have log base 20 of x, and then we carry the 2 down, so we have g of x equals to 2 log base 6, and then x plus log base 6, and then log base 20x. One common mistake that my students make in the past is they believe that, okay, we carry the 2 down, so we finish the derivative. The answer is no, that is wrong. We haven't done the derivative. We haven't done any derivatives yet. We just rewrite the function, all right? So now we are start doing the derivatives. Okay, what is g prime? So g prime of x, this is a base 6, so we have a x times ln 6, and then the 2 stays on top. And then we have the x is log base 20x, and then times ln 6. I should use a parenthesis for the log, and then ln 6 looks like that, and then we have a 1 on top, and then we have to multiply the derivative of this log. This is by chain rule. What's the derivative of that? The base is 20. So we have a ln 20, and then the independent variable is x, so this is x times ln 20. All right, and this is it. That is the derivative to the second function. So the third function, let's copy the function one more time. We have f of x equals to 12 to the x power multiply log base c, and then we have tangent 18x and then minus 5 pi. All right, so this is our one term times the other term that we will be using a product rule. So product rule, what's the product rule? Product rule is fg plus fg, f first, g second. F prime of x, the derivative of 12 of x is 12 of x times ln 12. I should space out my work because otherwise it will be hard to read, right? So we have a ln 12 times 12 to the x. And then the log, copy the log one more time, log base c, and then you have tangent 18x minus 5 pi. You can make a dot in here to make everything looks prettier, and then plus 12x. And then what's the derivative of log? The derivative of log is you carry the entire parenthesis down first, so you have tangent 18x minus 5 pi, and then you have to ln the base, ln c, right? So the top is 1, and then you multiply what? You multiply chain rule, right? So you have this, you have to multiply this using the chain rule. The derivative of tangent is secant square, so you have secant square 18x, the derivative of 18x is 18, and then the derivative of 5 pi is equals to 0. So this goes to right here. I put it up so I don't have to squeeze my handwriting. All right, so that is the end of this video. If you like it, you think my teaching fits your learning, give me a like, share the video for me, click the subscribe button if you are new to the channel, and I will meet you all in the next lesson. Signing out.